Okay, so number 11 on the review packet, we're going into a partition segment. So this is the partition questions, okay? Now, what we want to do is, if we want to get a ratio of 1 to 3, what we have to consider is that means we need 4 equal parts. What you're going to do is you're going to add the two numbers in the ratio together, and that's how many equal parts you're going to need, okay? So we're going to have to consider that. We need 4 equal parts. Now, we have a directed line segment AD. That means you have to start at A and catch all the points from A to D, okay? That includes all these, even though they're not numbered or lettered, they don't have a letter name, all of these points count as well, okay? Remember, a segment is all the points on a straight path from A to D here, okay? So it could be anywhere. Now, hopefully we can take this segment and easily split it into 4 equal parts. Let's find out. There are 1, 2, 3, 4, 5, 6, 7. It's perfect. There's 8 equally spaced points, it looks like. Okay, so there's 8 points along this segment, and that's going to work out perfectly. So every 2 is going to give us one of the equal parts. So watch this. So if I split it up in this manner, okay, what do I get? Well, I get 4 equal parts. There's one right here. There's another. There's a third. There's a fourth. So I've got now 4 equal parts. Now I have to move from A to D, and I got to get a ratio of 1 to 3. That means right here, because that's one of the parts to then 3 on the other side. This point right here at C is going to split the segment A to D into into a ratio of 1 to 3. A to C being 1 equal part, and C to D being 3 equal parts. So there's your 1 to 3 ratio. The answer then is determine the point that divides the directed segment. Okay, it's going to be point C. All right, that's going to be our answer. Okay. All right, so now number 12 is find the coordinates of the point on the directed segment from A to B that partitions the segment into a ratio of 3 to 1. Okay, so again, we look at 3 to 1 means we need 4 equal parts. Okay, so if it was 3 to 2, we'd need 5 equal parts. Say 1 to 6, we'd need 7 equal parts. That's kind of how that works. I know both of them have been 3 to 1 so far, so it's misleading. We're not always going to need 4 equal parts. That could change depending on the ratio. So let's go ahead and plot -7, 8. Okay, so I found points A and B. Just speed it up a little bit. Now, here's what I'd want to do. I want to break this up into 4 equal parts. But first, so the way I do it, if I can, is I go ahead and I count the sides here. Okay, if you count from A down to B, it's 8. The rise is 8. From A across to B, the run is 4. Okay, you only really have to do this either way. So consider the rise is 8 total, right? The run is 4 total. Now I want to break that up into 4 equal parts, right? So here's what I'm thinking. 8 divided by 4 is 2. 4 divided by 4 is 1. So it's kind of like going, okay, it looks to me like I'm going to have to go down 4 over 1. That's going to get me one of the equal parts. Sorry, down 2 over 1. Down 2 over 1, down 2 over 1. That's going to be perfect. You're going to get, look at, 4 equal parts out of that. That's exactly what we needed. Now be really careful. This is A. You have to label it right. This is A. This is B. Okay? It's got to be 3 to 1 going from A to B. That's what the directed segment means. So you actually have to go to this one so that you get 3 parts from A to whatever this is. It doesn't say, does it? Yeah, we'll just call it C. So we have to go 3 parts from A to C, 1 part from C to B. that location is 1, 2, 3, 4, 1, 2. So that looks like C is at negative 4, 2. Okay, so that's what we're looking to do. All right, keep going. Let's see. Okay, distance. Distance, we're going to do that same method on the graph. Okay, I like going from A to B. I like creating this right triangle. Go down from A as far as you need to match up with B. And then, there you go. That's our right triangle. The rise is 3. The run is 1, 2, 3, 4, 5, 6, 7, it looks like. Okay, and then we'll call the distance D. All right, I'll throw the work over here for A. So what I'm going to be using is Faggin Theorem. A squared plus B squared equals C squared. All right, C is always the longest side across from the 90 degree angle. So 3 squared plus 7 squared equals, we're going to change it to D squared, just because I put D there. You can leave C there, however you want to do it. That's going to be 58. And it doesn't say whether we're allowed to round or not. When you type square root of 58 in your calculator, you're going to get a little over 7. So I don't know exactly what you get. It doesn't matter. I have to leave it square root of 58. I cannot round. If it doesn't say round, you have to get the exact answer, which is square root of 58. Okay. Now, for B, there's a couple ways to do part B. Okay. For equidistant, the definition of perpendicular bisector, the definition of that, perpendicular bisector is perpendicular bisector, sorry, is all the points that are equidistant from the endpoints. Okay, so one way to solve B is to find the perpendicular bisector and see if it happens to run into P. I don't believe that's what they wanted here. I believe what they wanted was for you to calculate, let me just get a different color going here. Maybe I'll do this in a thick green here. Okay, I think they want you to calculate the distance from A to P and then the distance from B to P and find out if they're the same. So let's do that, and then we'll come back to, what I thought we could have done. We'll come back to that on C. So here's what we're going to do. We're going to do the distances. We're going to calculate the distances. All right. First, we're going to go A to P. All right. Let's get the numbers here for that. That's going to be tricky. Okay. So it looks like the run is 1. Let me just get rid of the other one here for a second. And then the rise is 1, 2, 3, 4, 5, 6. Okay, so we get 1 squared plus 6 squared equals D squared. Again, I use D for distance, but it doesn't matter what you use. So that's going to be 37. And when you take the square root of both sides, it doesn't work out. It's like 6 point something, really close to 6. So I'm going to find out, is P to B the same distance? So let's quick do that. I don't believe it's going to be, so, but let's check. 1, 2, 3, 4, 5, 6. Oh, there's no chance, because there's no way 6 squared plus 3 squared can possibly work. We'll call it something else here. Let's call it x. All right, that's 45. Okay, so, of course, they're not equal. So basically we're going to say AP is not, actually what do we want? Okay, so since AP is not congruent to PB, P is not equidistant from A and B. So that answers part B. All right, let's finish up. Is point P on the perpendicular bisector? No. was, if P was on the perpendicular bisector, P would have to be equidistant from A and B. That's by the definition of it. You know, a perpendicular bisector's definition is it's got to be all the points that are, it's got to contain all the points that are equidistant from both endpoints, and it's not. Okay, now part D, we have to find the equation of the perpendicular bisector. Okay, so this is where what's great about what we had going. Back to the original here, let's get rid of some stuff. So I'll get rid of all this. Don't need D anymore. This was 3. Okay, so here's what's got to go on in this. We're going to have to find the midpoint of AB. All right, that's not going to be easy. It's going to be a decimal, I think. It's got to be because, yeah, these are odd numbers. So if the rise is 3, the run is 7, the middle of that, you're going to have to go 1.5, right? Half of 3 is 1.5. Half of 7 is 3.5. So it's going to fall right there. Okay, that's rough. Let's see, the location of that, there's the origin. It looks like it's at -1/2, 1.5? No, -1/2, 2.5. Okay, let's just call that M. M for midpoint. It's -0.5. Is it 2.5? Let me go double check that again. 2.5, yes. So -0.5, 2.5. All right. Now, equation. Okay, so now that gives us a point that the perpendicular bisector has to pass through. All right, the slope of AB, this was rough. Slope of AB, now if you remember the rise over run, right? The rise is the up and down, the run is the across, and then now we got to determine is it positive or negative. It's going, as we move left to right, it's going down, so we have a slope that's negative. Okay. Wow. All right, the perpendicular bisector has to pass through the midpoint of that segment, and it has to be perpendicular. Okay, so perpendicular to AB, the slope has to be 7/3. Okay, we have to flip and change the sign. When we say negative reciprocal, it's like if we multiply a negative times a negative, it's a positive. So that's why you see, I'm not going to put 2 negatives in there. That's a positive. So remember, perpendicular symbol. There's a lot going on here. Wow, we're not even done. So y minus y1 equals mx minus x1. Okay. And here's the point that the perpendicular bisector has to pass through. That's x1, that's y1. So y minus 2.5 equals 7/3 x minus -0.5 is going to be plus 0.5. Wow. All right. Hang in there. Do the best you can on that. That was a rough one, but that's what it's got to look like. Okay, that's part D. You can leave it that way unless your teacher tells you it's got to be in another format. Sorry that that was a long video, but should probably kick this one over to the next one. Thanks so much.